In this video, I will show you how we use ModelSim to design test bench simulations for each individual component of our project. So, opening ModelSim, we went right here into this tab that says File. Then we open a file, then browsing through our projects directory right here. On the RTL folder, there's a TB folder, which stands for testbench. Each one of these files is a test bench for each individual component that makes up for the whole project. On this example, I'm going to show you the sender test bench. So once we open it right here, let me just show once we open it right here, it opens the code. Then we go right here into compile. Then we look again for the same file that we want to compile. So we go right here again in RTL TB, the test bench one, open the sender, then compile. Then it's gonna say the library work does not exist. You want to create this library, we create this library, and as you can see, it finished compiling with 0 errors and 0 warnings. Now we have this library right here. We can close this one. Then we have the sender test bench entity, which we can just right click and simulate. Once we do that, ModelSim will open up a wave simulation, which shows the sender and all of its components right here by the side. Then we just click add wave. Then all the signals are visible in the wave. Then we can let it run for around 1 millisecond. Restart the wave format just to make sure that the new timestamp is correct. Then we can just click on run right here. You can see it's pretty instantaneous. We can also click on the wave and on this blue zoom icon right here, and it shows all the parts we did. I'm gonna zoom in right here a little bit, to our left at least, around here. And you can see right here we're validating each individual component for each segment of time. We see how they work out. So we see that the data starts at 0, then it's changed, then the data in value the same because it starts only with the mask value that is right here on the bottom. Then we get a new data, get it together with the mask, encode it, and send it to the receiver. You can use this as well with other components to validate it, and you can also do this on hardware using the FPGA DE10 standard board, and you can also use a logic analyzer to visualize your signal. In our case, we use the SALA Logic 8 analyzer with the Logic 2 software in order to visualize the signal coming out of the board. You can see it right here, I think, on this segment. It's because it happens very fast, but I think we can. Yeah, so we see the pulse right here. That it says that the freeflow can be written, and we validate our component this way. Then, and just as I said, you can use the board to validate it. The only thing that is hard to validate is the receiver, since we didn't have an adequate signal generator. We first work on our own version of a signal generator that could be later encoded and sent. And with that version, we tested the receiver. If you have another signal generator, you can test the receiver to see if it was receiving your signal as well. And that's it.